going to use a TI-84 to find all the solutions of the given equations, correct to 2 decimal places. The first equation is natural log x equals 5 minus x. I'm going to solve this by letting the natural log of x be our function f of x, and 5 minus x be our function g of x, and find out where these graphs cross. So we're going to graph y equals f of x and y equals g of x. So using the graphing calculator, we're going to go to the y equals screen. We're going to go natural log x as our first function. Enter. And we're going to go 5 minus x as our second function. We'll go zoom, standard, zoom 6, and we're able to see a point of intersection there. So I'm going to go second calc and use intersect 5. Now it says it's starting on the first function, natural log x, and it will be starting at the x-axis where the natural log of x is undefined. Notice there's a blank beside the value of y. As we move to the right, though, you will see y values, and we will go close to the intersection point in the first quadrant. Then hit enter. Now the graph has changed to the function has changed to y sub 2 equals 5 minus x, and the cursor is already pretty close to the point of intersection. So I'm going to press enter, and then press enter one more time and let the calculator do the guess. And so correct to 2 decimal positions, we have the intersection point, the value of x where they intersect, as 3.69. At approximately 3.69, both the left and the right side have a y value of very close to 1.3. In the second equation, we'll use a similar process. We'll let f of x equal log x. We'll let g of x equals x squared minus 1. And we'll graph y equals f of x. That'll be our y1. And y equals g of x will be our y2. So I'll go back to y equals. I'll go clear, down, clear, move back up, enter log x, close the parentheses, hit enter, hit x caret 2 minus 1, and again go to zoom standard, zoom 6. Now here it's a little harder for us to see what is happening. I'm going to go and zoom in at the origin, and that's our default point of zooming in, so I can go zoom, 2 for in, zoom in, and enter. And we see that there are 2 points of intersection. One close to the y-axis, and one somewhere around x equals, I think, 1, depending on what those tick marks are representing. And so let's work first of all on the left intersection point. So we'll go second calc, hit 5 for intersect. We have log x as our first function, hit enter. I'm not going to hit enter yet because I see there's no value listed for y yet, so I'm going to hit the right arrow. And now we have a value for the y that is fairly close to that intersection point. So now I'm going to hit enter. And now I'm going to move along the second curve, x squared minus 1, staying close to the point of intersection using the right arrow. Now I'll press enter again and enter one more time. And our x value is approximately to 2 decimal positions, 0.10. At that point, both of the y values are very close to -1. The value given here is -0.99, rounded to 2 decimal places. So our x is approximately equal to 0.10. But now we have to go back to the graphing calculator because there is a second intersection point. And so let's go second calc again. 5 for intersect. We're back to the log x graph. And let's use the right arrow to move close to the second point of intersection. Press enter. Now the blinking cursor is on the lower function, which is x squared minus 1. Y equals x squared minus 1. I'm going to move maybe 1 space to the right there. I'll hit enter and hit enter again. And this time we have the intersection point is exactly at 1, 0, and we'll explore that. So when x equals 1. So our second value of x is x equals 1, and we can see when x equals 1, common log of 1 is 0, and 1 squared minus 1 would be 1 minus 1, or 0. So there are 2 solutions here, 2 values of x. So we are looking for the values of x close to the closest 2 decimal positions. The third equation is e to the x equals the opposite of x. So we'll let e to the x equals f of x, and the opposite of x equals g of x, and we'll graph both of these, y1 and y2. So going back to the graphing calculator, back to 1, y equals, clear, down arrow, clear, up arrow. So now I'm going to enter e to the x by doing second natural log x, close the parentheses, hit enter, and the opposite of x. We'll go zoom 6, zoom standard. There's our e to the x. There's our x, our opposite of x. We see that the intersection is in the second quadrant. Let's zoom in to the origin once. So zoom, 2 for zoom in, enter. And that allows us to see that intersection point much more easily. And so we'll go to second calc, 5 for intersect. First of all, it's the e to the x curve. I'll use the left arrow to get a little bit closer to the intersection point. Hit enter. And then on the second curve, I'm already close, so I think I'll just hit enter. And then hit enter one more time. And the point of intersection is negative 0.567 as an x value and positive 0.567 as a y value. And so notice that because it has to be on the line y equals the opposite of x, the two coordinates of the intersection point are opposites of each other. So the x value is negative 0.57. And the solution to 2 decimal positions is negative 0.57. There is another way to solve these. We could actually take an example like this last one and move both terms to the same side. So in this case, we could add x to both sides of the equation and get x equals 0. Doing that, we get a new function on the left-hand side that we can let equal y1. And instead of using the intersect feature of the calculate menu, we can use the 0 feature. And so let me just illustrate this for you. So we'll go back to the y equals screen. And this time, let's do our clear and our clear. And enter one function this time, second natural log x, close the parentheses, plus x. Now this is a new function. We go second calc, and instead of using 5, we can use 2 for 0. And it asks for a left bound, and so we'll use the left arrow to go to the left of the 0. Hit enter. Use the right arrow to go to the right of the 0. Hit enter. Hit enter a third time to let the calculator find the value. And notice that the x value, again, is equal to negative 0.57. You can use either of those methods, either the intersect method, where you enter 2 functions into your calculator, or you can set one side of the equation equal to 0 by moving your terms all to one side and use the 0 feature.